that's what we're going to be talking about today. What you need to know is they will have the same shape and proportional dimensions, okay? Not identical shapes. Same, not identical figures. Same shape, so a rectangular prism and a rectangular prism, or a cube and a cube, or a triangular pyramid and a triangular pyramid, okay? Will there be a cube and a cube that are not similar, that are not proportional?
No, because they all have to.
Right, so if it's 3, 3, 3, and 4, 4, 4, it's always a 3 to 4 scale factor, right? Can there be a rectangular prism that is not similar to a rectangular prism? Yes, those don't have to be similar, right? Can you have a sphere that's not proportional to a sphere? No, those will always be similar also, okay? So cubes and spheres will always be similar. Anything else could potentially not be. Where did I put those? Right. Okay, so here's what we're going to start with. The question is, are they similar? And I'm going to give you a couple pictures. And if they are similar, give the scale factor. That was a really weird way to write that. I'm sorry. Give the scale factor if your answer is yes. So let's say we have this picture. You have a rectangular prism where this is 3, 3, and 2. And another rectangular prism. These are not drawn to scale, sorry. Use your imagination. It's good for you. 6, 6, and 4. Okay, so I want to know, are these two figures similar? In other words, are they proportional to each other? How do I tell? How do I tell?
It's one of the two, because if you look at 3, 6.
Right. So you have 3 to 6. Right? You have 3 to 6. And you have, no, 2 to 4. Right? But all three of those, when you reduce them, are 1 to 2. So as long as they reduce to the same scale factor, like that, then yes, they are similar. So the question, are they similar? Yes, their scale factor is 1 to 2. And just make sure that you always reduce your scale factor as low as it can go. Okay? So far, so good?
Yes.
Okay, how about this one? That's okay.
I'm still trying to draw a rectangular prism.
We'll move on to the next one because these are rectangular prisms too.
Oh,
Let's say this is 2, 3, and 2. And this is 3, 6, and 3. Okay? I want to know, sorry, I didn't do the dotted lines on these ones. You were supposed to leave at 1:35. That was 5 minutes ago. Okay, so if this is your setup, and we ask, are they similar? Yes or no?
Well,
Yeah.
because they all,
well, actually, because we have to know if they reduce down or not.
Mm-hmm. Okay, so here's where people often make the mistake on these problems is they go, well, this is 2, 3, 2, and this is 3, 6, 3. That seems to follow a pattern. So yes, they must be similar. But you're doing 2 to 3, right? and then 3 to 6, and then 2 to 3. Okay? So 2 to 3 and 2 to 3, those are the same, but 3 to 6 reduces to 1 to 2, and that is not the same. Right? So the question, are they similar? Your answer here is no, they have a different scale factor. Okay? So just be careful with your numbers, that you're not just looking at, do they kind of follow a pattern, or are they the same scale factor? Okay? Questions on that? Okay, so remember last chapter, I think it was last chapter, yeah? You did scale factors, perimeter ratios, and area ratios. You remember that?
Yes.
Okay, do you remember the relationship between them?
No.
Like if my scale factor was A to B, then my perimeter ratio was A to B. What was my area ratio? Do you remember? A squared to B squared. Right. Okay, we're going to deal with that in this section, but we're also going to take it up a notch and do volume ratio. Any guesses what the volume ratio might be?
A
Cubed.
Right, we're going to cube them. So this one's A cubed to B cubed. Okay, so scale factors A to B, area ratios A squared to B squared, volume ratios A cubed to B cubed. Okay, what you're going to do with that is a problem like this. So this one, they'll say find the scale factor. If the volume ratio is 3,375 to 1,728. Okay, so this right now is representing our volume ratio. We want a scale factor. So look back at the chart we just made. How can I get from here, from a volume ratio, and turn it into a scale factor? What would I have to do to this one to make it, so A cubed to B cubed to make it A to B?
You have to do the square root of 3.
The cube root, right? Yes. So what you're going to do is you're going to take the cube root of this. Now, you can plug it into your calculator, but it's probably going to give you a decimal if you plug it in like that. If you plug it in as two separate problems, so the cube root of 3,375 and then the cube root of 1728, that will give you nicer numbers. Otherwise, you can just use a key to turn it into a fraction again. If you know where that key is on your calculator, that can work too. But for this, can anyone tell me what's the cube root of 3,375? Plug it into your calculator. What do you get? 15. Okay, so that is 15. What's the cube root of 1,728?
12?
That would be 12. So our scale factor is what? Almost. You have to reduce it, yes. Okay, so your scale factor is indeed 15 over 12, but you want to reduce. Okay, so 15 over 12 is actually what? 5 over 4. So your scale factor is 5 to 4. So take the cube root and then make sure you reduce. Okay, you could reduce initially and then cube root too, but it's easier just to cube root the big number than to try to reduce huge numbers. Questions on that? Okay. Then, how about this one? If I tell you that the volumes of two similar solids are 40 cubic inches and 135 cubic inches. If the surface area of the smaller figure is 48 square inches, what is the surface area of the larger? Okay, so you have two volumes. You have the volumes of your two similar solids. So they're proportional, okay? They give us one surface area. We want the other surface area. So which ratio do we know right now? Do we know scale factor, surface area ratio, or volume ratio? Volume, right? Because we have two volumes. We have 40 and 135. So my volume ratio is 40 to 135. Okay? I need to turn that into a surface area ratio so I can set up a proportion. Now, here's the deal. You don't have to reduce at this point if you're going to just plug everything in one shot. But I feel like most people don't do that. So what I would do, if I were you, is I would reduce your volume ratio. And then what happens is you'll get beautiful cubed numbers. Can anyone tell me what 40 over 135 reduced would be? 8 over 27. Yes, 8 over 27. Okay, so if that's my volume ratio and I need to get to surface area, how do you get from volume? What?
Well, you can go into the scale factor, which would end up being 2 over 3.
Right, so you cannot jump straight from volume to surface area. You need to take it down to the scale factor first, which means you're cube rooting 8 and you're cube rooting 27, which is 2 to 3. Okay, so that's my scale factor.
And then you can square both.
Then to make it your area ratio, we're going to square those. So that would be 2 squared to 3 squared, or 4 to 9. Okay? So you have an area ratio now. They told us that the surface area of the smaller figure is 48. We want the surface area of the larger figure. So what is your proportion going to look like?
4 over 9 equals 48 over x.
Right, 4 over 9 equals, now the 48 has to go across from the 4 because it's the smaller one, right? And they gave us the smaller figure. So the x on bottom, and now you just cross multiply. So we're going to cross multiply this. 9 times 48. Oh my goodness. What is it?
9 times 48
Yeah.
is 432.
Okay, so 4x equals 432. Okay, and then divide by 4. And we get x equals 108. What are my units here?
Inches squared.
Inches squared, because we just found an area. Okay, that's a surface area. That's the whole problem. Now here's my concern. Remember last chapter when I warned you and warned you and warned you about a question that a lot of people do wrong on the test? And then you took the test and a lot of people still did it wrong? This is just like that problem where you have to reverse first and then move on. So here's my warning to you right now again. This is a problem that often trips people up, not because I don't think you know how to do it, but just because there's several steps to it that you forget to do one of the steps, okay? Make sure you go from volume, you cube root it, and then you square it. And that will get you to setting up your proportion, okay? Questions on that?
There's no fancy shortcut, is there?
Well, the fancy shortcut would be to plug it all in as one big thing, which you can do. But yeah, I feel like you make silly mistakes when you do it that way. You miss a parenthesis, or you miss a square, or you miss
The last lesson
something.
you can put it in, but this one is,
I mean, you can. I feel like this one's even more work.
it's more work to plug it all in.
Yes, than to just solve. Right.
Not that
Okay.
much.
What?
I said it's not that much work.
No, it's not bad. It's just there's several steps. You got to make sure you just do all the steps. Okay, last question. Example 4. I'm going to write this one out because I want you to talk me through it. I want you to tell me what you have to do, not me tell you what you have to do. So bear with me. And I'm going to kind of write it shorthand so that it's not so many words, but I want you just to understand the problem. So Office Max sells paper clips in 2 different boxes. You have a small box and a large box. A small box of paper clips holds 220. Okay. A large box is formed by doubling the dimensions of the small box. What's going on? I want to know how many paper clips will fit in the large box.
So is the 220 like that's all that will fit into the box?
220 is what will fit in the small box. So if it's, I need you to think about what is area, what is scale factor, what is volume, what are we working with here? So if they're saying a small box holds 220 paper clips, is that scale factor, area ratio, volume ratio? That's volume, right? We're talking about the volume here of the small box. Okay, so this is volume. It says the large box is formed by doubling the dimensions. If we're talking about the dimensions of something, which ratio are we talking about? That's the scale factor, okay? So this one, being your scale factor, what is your scale factor?
1 to 2.
If you're doubling, it's a 1 to 2 ratio, right? You're doubling. So your scale factor is 1 to 2 right now. I want to know how many paper clips fit in the large box. What am I finding? The volume. Okay, so we're looking for volume. We have scale factor. So we're going to do a volume ratio of what?
Your volume ratio would be 1/8.
Right, you're cubing your scale factor. So 1 cubed over 2 cubed is 1 to 8.
And then you just set up the proportions.
Right, so this is our volume ratio, right? 1 to 8. We know the volume of the smaller one is 220. So I'm going to say 1/8 equals, where does the 220 go?
On the top.
On the top, across from the smaller of the two, because this is the small box. So 220 here, x here, and then you cross multiply, okay? So that comes out to x equals 1,760 paper clips. Okay, so stop and think about what numbers they're giving you. When they say the dimensions, they're talking scale factor. If they're talking about how much it holds, they're talking volume. If they're talking about the surface of something, they're talking area, right? So just make sure you have the right ratios there. Questions? All right. You have 20 minutes, which is a decent amount of time.